Hello everyone, my name is Sainath, and in this today's video we are building a serverless AWS cloud cost optimization project. And in this project we are looking into 9 different AWS services, out of which we are mainly focusing on two different services of AWS, that is EC2 instance and EBS volumes, because these are the two main services that are contributing to your uh, cost in your organizations. So we'll try to optimize them, and by end of this video you will get the basic understanding of how cloud cost optimization is implemented, that to serverless. Though we are not covering all the services of AWS, but you can add on top of this your services that you are using and try to optimize them. And we also be building a dashboard where we'll try to visualize all the issues in our AWS account, and we'll try to take actions on them, on that issues on just one click. We'll be building a comprehensive dashboard for that. So yeah, without getting late, let's get started. So before getting started, let first me explain the architecture of our application, that is AWS Cloud Cost Optimization. So as I told, we are using 9 different AWS services. So which are those services? We are using EC2, EBS, CloudWatch, EC2 cost optimization, and we are using Lambda, DynamoDB, API gateway, and we are using this IAM policies for the creating rules for our Lambda functions, and we also be using EventBridge. So now let me explain the flow how it goes. So we'll be analyzing these two main services of AWS, that is EC2 and DBS. So the data will be fetched from CloudWatch. CloudWatch is the one who tracks all the data, means CPU utilization, disk utilization, memory utilization. All the data will be present in CloudWatch. So we're using taking the help of the from CloudWatch, and we are also using another service, that is EC2 cost optimization. So what is this? Let's say you are using a instance, T2 large instance, and you're not using that instance to the point, means the workload you are executing on that instance can also be executed on some other instance, lower instance like T2 medium. So that is what this uh, service will recommend you. And these are the two Lambda functions that we are using. One is EC2 analyzer and one is EBS analyzer. Don't worry what actual these two things are doing, that will I explain next part of this video. But just understand, now we are using these two Lambda functions, and these two Lambda functions are scheduled using EventBridge. And whatever the data coming from and whatever the data coming from these two Lambda functions will be stored in this DynamoDB. So why DynamoDB? DynamoDB is like NoSQL database, like your MongoDB, which is very helpful to store the unstructured data. So we are using this DynamoDB to store the data. And then next we are using the another Lambda function which is connected via API gateway. Why API gateway? Means we want to fetch the data from this DynamoDB, or we need to update the data inside this DynamoDB. For that we are using this API gateway, which will be triggering this Lambda function. And what Lambda function do, I will explain that in next part of this video. And we'll also create a dashboard for that, where we'll display all the recommendations, filter our services and all here, and the AWS IAM services for our Lambda functions to create roles and give permissions. So yeah, this is the flow of our architecture and flow of our application. So yeah, we'll start building now. So now first let me explain these two Lambda functions, this EC2 analyzer Lambda and EBS analyzer, what these two Lambda functions are doing, and also this Lambda which is connected to our API gateway. So, and I also created this GitHub repository where I pushed all the code of this project. So you can check this out also, where I explained each step one by step by step, explaining how to set up also everything I have explained in this repository. You can take a look at this. So yeah, we'll look into our EC2 analyzer Lambda. So in this function, what we are doing. So now just ignore these things. What we are doing. just we are importing Boto 3. What is Boto 3? Boto 3 is a tool that helps us to provides different functions that helps us to communicate with our AWS services. So in this function, first is what we are doing, that is ideal check, instance check. Means this instance, by this what we are doing is we are checking if the instance is underutilized or not. What we are doing is we are taking all the instances of our AWS and checking its value whether it is running or not. If it is running, then we are tracking. If it is running, then what we are doing, we are taking the last past 7 days data, get the CPU utilization of past 7 days of that instance. And how we are getting that data? Through this CloudWatch. So we are using here CloudWatch. We are importing through this Boto 3 library only, that CloudWatch. Same EC2 also, and same DynamoDB also, and same compute optimizer also. And we are creating a table also. So now we are tracking the past 7 days data. And for past 7 days data of CPU utilization. And how we are doing that, let me explain that also first. What How it is getting is, means for past 7 days, for each day, means day 1, day 2, day 3, day 4, 5, 6, 7. For each day we'll be having certain graph like this. CPU utilization may go up and down, up and down, we'll get a certain graph. So for this day we'll get an average. We got some average, let's say A. We got a, for day 1 we got a average as A. Similarly we'll get some average for day B also, sorry, for day 2 also. Same for day 3. Similarly we'll get a 7 averages, 7 data points. So we'll sum that, will sum. Here we are summing that. Adding means all we are adding that 7 data points, and we are dividing that by number of data points. So by that we'll get our average CPU. And if the average CPU is less than 5%, then we are adding that in our table dot put item. What is this table? Here it is. Table is a DynamoDB table cost optimization. This is the name of our DynamoDB table. So that in that table this data will be added: the resource id, service, issue idle instance, and recommendation is stop or terminate. This is what in our DynamoDB will be stored. And the second part, we are using this compute optimization recommendation. This is itself a AWS service, and we need not to perform any logic here. This will do its own work and will recommend us whether the instance is over provisioned or under provisioned. So here it will also track all the instances and find whether the instance is over provisioned or not. So if the instance is over provisioned, we'll putting the adding that instance in our table. Instance id, service, issue as over provision, and recommendation as uh, which other service instance type we can use. This is what we are storing here. And this is it for our ec2 lambda function, sorry, ec2 lambda analyzer. So now we are looking into ebs analyzer lambda. So in this we are doing the same thing. We are importing boto 3 library. We are creating the client of EC2, CloudWatch, DynamoDB, and table. And in this, we are performing many things. Like first is we are tracking the EBS volumes. Means it will first see, filter out all the EC2 in the EC2 dot describe volumes. Filter out all the volumes of the EC2, and we'll check if the volume state is available or not. Means available means the EBS volume is not attached to any of the EC2 instance. And it will check if the state is available or not. If it is available, then it will simply add that in table saying services EBS, issue unattached volume, recommendation, delete if not needed. And next we are doing is GP2 check. Means if you not know, AWS also has different types of GP volume type, that is GP2, GP3, and many other. GP2 is the one older version which is not much good as compared with as compared to GP3, as compared to cost also and other different customizations also, because GP2 does not provide many customizations as compared to GP3. So if the volume type is GP2, we are adding that data also in our table, saying resource ID, service, issue as volume GP2, recommendation migrate to GP3, and also as compared to cost also, GP3 gives 20% lower cost as compared to GP2. So that is what we are doing here. So next is provisioned volume check. Means what we are doing is here, let's say you have your created a volume of 100 GB, but you are not using all the 100 GB. Let's say you are using only 15 GB or 10, 20 GB of volume. But unfortunately, AWS CloudWatch does not track the disk usage of your instance. So for that we need to set up a CloudWatch agent in your instance. Means you have a EC2 server running, you need to set up a CloudWatch agent on that server, so that it monitors all the usage of your instance and send that data to CloudWatch. And from there, if the we are doing the same thing, if we have any such instance, we are tracking its 7 days data and taking average points. And if the average used percent is less than 30, we are adding that in our table, saying over provisioned, consider reducing volume size, currently using only this much of size this. So this is what this is doing. And next is old snapshots. Let's say in organizations, we create a snapshots of our instances, and if that instance is like uh, much more older than our threshold, like we are setting up here a cutoff day. And what is that cutoff day? Here for demo I have used one, because but in organization it is normally 90 days. So that is, if the threshold start time, means the day it is created, is less than 90%, 90, then simply we add that in table, saying old snapshot, and we need to take a review or delete that snapshot. So these are the functions in our EBS analyzer. Okay, now let me explain this API Lambda function. So we have done explaining these two functions, and these two Lambda functions are scheduled by our event bridge, and this Lambda function will be triggered by our API gateway. So in this Lambda function, what we are doing is this Lambda function, as I told, will be triggered by our API gateway. And if in that API gateway we are performing different things, like if the method ignore this, I have added this as for testing purpose. So if the method is get and path ends with slash recommendation, what is this slash recommendation? Just understand this. I will explain this in when we are creating our Lambda, sorry, API gateway. If the method is get and ends with slash recommendation, means we need to fetch all the data from our DynamoDB table. So response is equal to table.scan and send that data from the here body. So we'll get that data in our dashboard. And other is we have this next is method as post and path ends with update status. Means in our dashboard we have multiple issues, and if that issue is resolved or has been performed, we have performed action on that service, we need to close that service. This is what this method does. Slash update status is updates the status to closed, and update the table and return a status code as 200. Next is we have another elif method as post, and path ends with slash action. Means we have multiple issues in our dashboard. Let's say we have a issue called underutilized EC2 instance, and we need to take action on that, like terminate or delete that instance or stop that instance. Let's say in our dashboard we'll give a simple button over that to take action, and if that action is performed, try if a service, here we are tracking it from body, we will get the resource ID, issue, action, and service. And if the service is EC2 and action is stop, we simply stop that instance from this EC2 stop instance function. Or if it is terminate, we will terminate that instance. And if the service is EBS, issue is unattached volume, action is delete, then simply we'll delete that volume. Or if it is old snapshot, we'll delete, and action is delete, we'll delete that snapshot. And finally we'll update the table saying that issue has been solved or closed. And then returning the status code as 200. If you'll get any exception, return the status code as 500. This is also same. So yes, this is what our lambda function, and this will be triggered from our API gateway. Yeah, now we are done with our theoretical part. Now uh, let's move to the demo part. Come to your AWS console, and we'll start first from creating our lambda functions. So go to your lambda. Oh, I have already created a demo on that now. Okay, let me delete this, and we'll implement it everything from scratch only, so that it gets clear for you guys also. So let me delete that first. So let's start from, so create a function, author from scratch, give the name, that is to analyze a lambda, choose runtime as Python 10, and execution role, use the existing role. Like I have already created the role, but let me show you again how to create that role. So we will be using this cost optimizer, EC2 cost optimizer role. So here just click this IAM console. You will be moving to your IAM console, and in there you need to choose these things, that is AWS service, use service as for lambda, and hit next. What all services you need is first is that EC2, you EC2, let me check which all choose the service as lambda, and hit next. And next you need to choose the permission policies for that, which I have given. Let me check that. Create a role, attach policies. So we need a DynamoDB full access. Paste here. DynamoDB full access. Yes, easy to read only access. Yes, and then CloudWatch read only access. Yes, and then we need to create this inline policy for our EC2 instance recommendation. So for that, what we'll do is permission boundary. Choose the instance. Just hit next. So you will find all those three here, and then hit create rule. Give the name for your rule. Let me give as a AWS cost optimizer PTI, and then create role. So you will get here is that AWS cost optimizer. Just click here once again, and you need to add one more policy, that is add permission, create inline policy. Go to JSON and just take this complete code from here, and JSON paste here. And then next, give the policy name as EC2 optimizer, and then simply create. So this is also added, and SEO policy is created now. Now move to again to back to function and use existing role. Just to refresh this once, and you will see your role as here. See, AWS cost optimizer role. Just click that and create function. So your lambda function is created now. And next is to come here down. It is buffering. So we need to add that code here. So come here and take your code from here. Take this complete code and just paste here, and then deploy. Yes, now it is deployed. And we need to schedule this now. So scheduling part we'll do later. So firstly we'll create all the functions. So next function is, now we have created this EC2 analyzer. Now we'll create a EBS analyzer. Lambda, choose runtime as again Python 10. Change existing roles, use existing roles. For this also you use this only, that is AWS cost optimizer role that we had created just now, and create function. And for this also use the code from GitHub only. You just paste that code, hit the deploy. So it will deploy your code and updating. Yes, and yes, your EBS analyzer also has been deployed. And next function is to create our API lambda. So choose runtime again as Python 10. For this we need to change, I think, maybe let me see whether we have created a different role for this. EC2 analyzer, EC2 create use existing role and add a API lambda role. So for this we need to use API lambda role. So create this role named. So first let me show which all things are there in this role. So come to your IAM role, go to roles and see for that. Let me show you that first. That is, what does that mean? Yeah, this is the role, and in this role, we have given a DynamoDB full access and created a inline policy. And in this inline policy, we have given these things. Don't worry, I will add this in our GitHub repository. You can take this from there only, and take this is a AWS managed, and create a policy named API Lambda role for DynamoDB. And then once the rule is created, now use existing policy. Come here and take that policy like this, and just create function. And now your that function is also created. And next is to take that code from here. Once it is created, deploy. Yes, now it is deployed. Now you have all three Lambda functions. So now we'll create a DynamoDB table. So come to your console homepage, go to DynamoDB, and in here we'll create a table. So create a table. Let me show first. I think I already have a table. Tables, yeah, I already have a table, cost optimization. So let me delete this also. So create a table, give the name as what was that name? Cost optimization, and then partition key as resource ID, and sort key by issue. Keep both as string, and keep everything as default, and just create table. Yes, table has been now created. It is in creating state. Wait for it to completely get created. And yes, table was creating was that simple. So yes, what all we have created now. So we have created this lambda function, and this, and we also created a DynamoDB table. So now let's create this API gateway so that we can trigger this lambda, and after that we will schedule these two lambda functions. So again, come to your console, go to API gateway. So in this API gateway, again I already created here. So what we do is, let's delete this completely and let's create it from scratch only. Delete. So I have deleted that. So let me create it from scratch. Create API. Choose REST API. Don't choose private. Choose REST API. Build new API. Name of the API. Resource analyze API. And the regional, keep regional IPv4. Create API. And once here you are create resource, give here the name as, I think it is a recommendation. So what is this recommendation? So whenever slash recommendation, so this is the path that I had explained in explaining our API lambda function. So whenever the slash get method is get, and path name is slash recommendation. So that is what I was telling. So give here recommendation, create resource. Once the resource is created, come to here create method, choose method as get lambda function, and make sure to on this. If you don't on this, you will get the course error on that. And uh, this method should trigger which lambda function, that is this API lambda. Choose that lambda function and keep everything as default, and just create method. Yes, now it is created. Once it is created, deploy API, go to stage. You don't have any stage, just to create stage, give the name as dev deploy. Yes, it is deployed. Now you will get this URL. Now this is the URL that you should invoke. This is the URL, just append slash recommendations after this, and you will able to get the resources. And we need to create another that is, so I have created this slash recommendation. So next is to create update status. Create resource, update status, create. So in this again create method. So update resources post method, because we are updating the resources of our table, DynamoDB table. Just click this, Again choose this lambda function because we are invoking this and create method. So we have post method for this, and once you are here, deploy here again. Choose stage, choose dev as stage, and then deploy. So it is deployed. Come to resources. These both are done, and next is to create actions. Actions, no action, action. Create resource. Here it is, and then create method. Action is also post method. Post method. Yes, method is post on this, and then choose this. Then create method, and then deploy dev deploy. Yes, here again you got the URL. Just after this, append slash action. All three resource API gateways are now created. So we have also created this API gateway. Now let's schedule these two Lambda. So for that we'll be using AWS EventBridge. So how we are scheduling this? So we will be scheduling this on such a way that that Lambda function should be triggered every day at night 12 a.m. I will show you that how to do. So come to a console, go to AWS Event Bridge, come to rules, and here I think I already created that. So let me delete this. These two are the rules that I had created. This is the managed one, CM managed. So simply delete. So now let's create that. Give name as EC2 analyzer scheduler, and keep everything is default. On default, choose the schedule and continue, and then we need to queue the cron here. So it is cron. So we will, as I told, we will be executing it daily at 12 a.m. night. So for that, this is the cron 30 18 star star question mark 30. So add that here 30, 18 star star question mark star. So see what do I mean by this? So this time 3018 is UTC based. So change to local time. See here. Wednesday at 12 a.m. Thursday at 12 a.m. At Friday at 12 a.m. It will run. So this 3018 is UTC based. By default it is. So once you will change to our local time, you will get this. So next, just hit the next. So we need to trigger what AWS service. Target is our lambda function, and then which function we need to trigger our EC2 analyzer, and then keep everything as default, and next create rule, and you this event has been now created. This is it. Now let's create for EBS also. Analyzer for EBS. Yes. EBS analyzer scheduler. Go to schedule, create rule. Here also give the same. That is what 30 18 star star. And if you want to know more about this cron job, you need to refer a video from YouTube, and then here also a star. So here it is also same local time. So this will also be scheduled at the same time. Hit next. service lambda function target which EBS analyzer. Keep everything as default. Hit next, next, create rule. So this is also scheduled now. Make sure these two are enabled. If they are not enabled, just go here and you will see here enable button, because my it is by default only enabled. And yes, now you have scheduled your lambda functions also. Yes, we have done setuping all things. Now let's move towards our dashboard. Come to a console. So again, I will not be explaining how I have set up dashboard and all, and you can take a look at here. It is just a simple React based application. So let me show you here. So here it is, and in this React application, created two pages. We have simple two pages, that is a dashboard, homepage, and login. And in dashboard, we have created these three handlers. One is to fetch data, other is to close the issue, other is to handle actions. What you do is just take a fork this repository, or take this or build your own dashboard and just replace this. What to need with what you need to replace it is come to your console and go towards API gateway. Let me show you that also. In gateway, come to stage, not stage, resource, action, stage. Here you will see that. Just take this, and after that append here slash recommendation. Same goes for this also. Just change that and append slash update, and here also. And it is once updated, it will work perfectly fine. And yeah, I built a simple dashboard out here. You can take a look out here what I've done. Now let me execute this. So pm run dev. So it is working now. Let me. So this is a simple login. Again, I have not built a very authenticate login UI. You can do it on your own if you want, because that's the completely different part from what we are doing now. And if you are like much more interested in doing that, you can do and create a pull request. I will definitely accept that, and that will also be your open source contribution, because that is how we all learn together. Now just simply log in, and this is our dashboard. So let me inspect and show you the data coming or not. So just fetch data, click this button. See, I didn't receive anything because our lambda functions are scheduled but not yet triggered. So what we'll do is we'll trigger our lambda functions manually and see our data in our this dashboard. So for that but there is something you need to listen first, that is these two EC2 analyzer, we need historical data of 7 days, but I will not be doing that, because we need a data of 7 days and I need to keep the instance running for 7 days straight. So I will not be doing that demo for you. And also for this also, compute analyzer, compute recommendation, for this also we need a data of 7 days. So this also will not be doing a demo if you have guys, because what, why I'm not doing that, because of this is just spiking. So we'll not be doing demo, but we'll doing demo on this, that is EBS analyzer. In this we can do a demo. So here we are unattached volume na, so we will be doing demo on this in GP2 also. And over provisioned volume, for this also we need a historical data of 7 days, so we'll not be doing the for that, and for old snapshot also. So for these three things we will be looking into demos. So for that, now let's create a volume and keep it as available. So come to your console, EC2, go to your volumes, Here it is, here volumes, and see in these all volumes are in use means these all volumes are connected to some EC2 instance. So let's create a volume. See GP3 by default it is GP3, but what we'll be doing is creating a GP2 volume. Give size as 10 GB, and then just simply create volume. See a volume has been created now. Let's refresh. See it is in available state, and this volume is of type GP2. And next is what I have told, we need to create a snapshot also na. So for that I think I already have one snapshot. Yes, I have a snapshot, so this will be triggered. Okay. But when it is created, so I have created this snapshot today only. So let's try. So yes, our data is created now. Let's manually trigger our lambda functions now. Come to your console, go to your lambda function, that is this, and in this EBS analyzer. So in this EBS analyzer, what we'll do is we'll trigger this lambda function now manually. And this manually that data will be added in our DynamoDB table. Once data is added in DynamoDB table, we will trigger our API lambda function through our API gateway. So for that, just click here test, create a test event, give any name here, just test API. Just save this. Now just simply hit test. So status has done, your lambda function has been triggered. Now let's move to your DynamoDB and see whether data has been added or not in our table. Come to your DynamoDB table. Tables, cost optimization, explore table. See, our data has been triggered and added. Unattached volume and GP2 volume, both, and status is open. Let's see that in dashboard also now. Let me inspect this first and just fetch. See, this is our dashboard where it is saying unattached volume, resource ID, recommendation, delete if not needed, estimated saving, and this is a GP2 volume. And now let's say you want to take action on this. Just take action, and that will be. So now we were getting that course error because we had not enabled a course in our API gateway. So we should open this options. For that you come to your API gateway lambda. So in this actions, just click here enable course, and you will find a save button here. Just save that, and your options course will be enabled. Then just click here options and just deploy it. Choose option as dev and deploy it. I've already done that, and then you this will be working fine. Your course will be enabled for that slash action. So now let's look into our demo once again. So now what we'll do, we'll trigger our lambda function once again. That is this our API, not API lambda. This our EBS analyzer. Manually we will trigger it once again, and we'll let this added data will be added in our DynamoDB table. So for that now, what we'll do is simply we'll hit a test, status succeeded is done, and our lambda EBS analyzer has been triggered. And now let's go to our dashboard and just fetch data. See, Now you should able to see the data, that is unattached volume we have, and GPT volume we have. Now let's say you want to close that issue. Now you have performed any actions on this volume and you can want to close that issue. If you want to close that issue, you can just simply hit this close issue. This issue will be closed. See, now let's say you want to take any actions on this, like you have here unattached volume. You want to delete that volume. You just take action, click here, take action. This will manually, not manually, automatically trigger this Lambda function. That is this API Lambda, and in this we have a function to delete unattached volume. That is, let me show you this. Here we have that slash action, and in this EBS we have unattached volume to delete volume. So this will trigger this. Let me show you that. Take action. Just fetch data once again. See here. Closed or deleted. That volume has been deleted. You can verify that by going to your console and check that. Let's see EC2 in volumes. I had volume available now. See, now I don't have any volume which is saying it is available. So that is how we perform demo, and we can perform demo on like others also, like our EC2 analyzer also. But for that we need 7 days of data, so we are not performing on demo on that. And yeah, that is how it is done. And you can also add much more features on top of this and can create a pull request. I will definitely accept that, and that will also be your open source contribution. And yeah, that's it for this video. We have successfully implemented a serverless AWS cloud cost optimization project, where we are mainly focusing on two main services of AWS, that is EBS and EC2, to reduce our cost. And top of that, you can add your own services of AWS and try to optimize your AWS bills and use that in your organizations also. And I have also created this GitHub repository where I explain each step how to implement this on your side. You can take a look at this. Also, don't forget to delete your resources. That is your firstly is your event bridge. In that rules, that is these two, EBS analyzer scheduler and EC2 analyzer scheduler. Don't forget to these two, either you delete or disable it. I will disable it, or else they will trigger your both lambdas daily at night 12 a.m., and that will eventually incur your cost. If you want to keep on it, you can, but still I'm disabling it. Or if you want to delete, or if you want to delete all the other services that you used, you can move forward to it and delete those all services. And yes, that is it. And if you are new to our channel, make sure to like and subscribe, because it really motivates for me to make more such content. And I'll see you in some next video. And in next video, I'll also be bringing a video on how to implement a Jenkins pipeline, secure Jenkins pipeline end to end from code checkout to production ready deployment on a server. That project I had done in one of the hackathon, where I won that as a second prize. I will show how to build that secure Jenkins pipeline for you in our next video. So stay in connect. I will see you in next video.